So this is the new chapter, which is all about inverse circular functions. So first we're going to start to understand this by looking at the regular sine function, and then just go back and remember how inverse functions work. So if you go in your book, you can see, or you watched on Khan Academy, it'll explain all of this, but what it comes down to is that the inverse of a sine function is going to is called the arcsine of that value, and it looks like that. Those are the trig values, right? So up there you've got so if the arcsine of 1 is going to be, the radian value, which corresponds to that trig value. So if the sine of x equals 1, that means x is pi over 2. But here the x's and y's are swapped. So you can see how, if the x is now the arcsine, so then that's the trig value. Y axis is giving you the radian value. As x gets closer to trig value of 1, the y value gets closer and closer to pi over 2. And then, as x gets closer and closer to negative 1, y gets closer to negative pi over 2. And then since we need it to be a one-to-one relationship, we just limit it from just those values of x between negative 1 and positive 1, and y between pi over 2 and negative pi over 2. Hey everybody, I just thought I'd do a quick explanation of the concept of inverse trigonometric functions. And the way you want to do this is just to start out by remembering what an inverse of a function is. So if you have a function like this, equals, y equals x squared, you remember that to get the inverse, you swap variables. So then x equals y squared, and then you solve for y, and then so if you do that, you get y equals root x. So then this looks like that, and so then you have this type of a relationship between the two functions. So with trig functions, what happens with the sine function is the inverse looks sort of like this. So this is going to be pi over 2 up here. This is pi over 2 here. So it just gets reversed, right? So you have this pi over 2 here, and then you have the x value is going to be 1. So that's the, 1 is the sine. But now that value is on the x-axis. So this function here is called y. You can write it this way: y is sine of negative 1 of x, or you can say it's y equals arcsine of x. So yeah, it's just the inverse of the regular sine function. So the roles are reversed. So the degree measure here is on the y-axis, and then the trig values are here on the x-axis. Alright, so let's do example 1. Find y if y equals arcsine 1 over 2. So you just have to ask yourself, what's the radian measure of the trigonometric where arcsine is 1/2, where the sine is 1/2. So that value is 30 degrees, which is the same as pi over 6. What if y equals sine to the negative 1 of 1? So what radian value goes along with sine being negative 1? That radian value is 3 pi over 2. So that's, 270. And the last one in this bit, y equals So is there a trig value that is equal to -2? No, does not exist. So remember that this is the same thing as y equals arcsine. So you're just reversing the trig value and the radian value. And then another important thing to note about these inverse sine functions is you'll notice that they limit them. So because you see how if this keeps going like that and this keeps going like that, then it's no longer a one-to-one relationship. So as you remember, in inverse functions are a one-to-one relationship. So that's why you need to just limit it to, for sine, you have to limit it between x values of negative pi over 2 and positive pi over 2. So that's something to remember about inverse trig functions. Cosine function, so that's going to be the same thing as arc cosine of 1. What radian values go along with the trig for the cosine, with a cosine value of 1? Only one radian value that goes with that, and that is, so that's just y equals 0. So the radian value is 0. So let's do the next one. Y equals inverse cosine of negative root 2 over 2. What are the trig values, the radian values, which correspond to cosine negative root 2 over 2? Go back to the old unit circle. So those could only be either this, so that's 135 degrees, or 3 pi over 4, or it could be here, 225 degrees, so that's the same thing as 5 pi over 4. So as you remember, there can only be one value, because in the inverse in inverses, it has to be a one-to-one relationship, so only one of these can be the answer. It can't be a 1-to-2 relationship. We must find the values of y that satisfy cosine of y equals negative root 2 over 2, where y is in the interval 0, pi. So they define it as just these values here, 0, pi. So this one is out. So the answer is y equals, if you're looking for the inverse cosine of negative root 2 over 2, it's going to be 3 pi over 4. So that, let's do, say, what if theta equals arctangent of 1? So here you just think about, for what radian measure will give back a value of 1. And if you remember the unit circle, those values would either be this 45 degrees or 225 degrees. Those are both have a, y equals, or yeah, tangent of theta equals 1. So this answer must be either 45 degrees, which is the same as 1/4 pi over 1/4 pi, or this one here, which is 5 pi over 4. In the universe of inverses, they just limit tangent. You remember how, like this, that's how the original tangent, the inverse of tangent ends up looking like this. So if you want to keep it one-to-one, you have to just go on this side. The range ends up being the same as just for as the original tangent function, so the range is between negative pi over 2 and pi over 2. So it can only be this. So it's pi over 4 radians. So that's theta.